Good afternoon, pilot teachers, and good afternoon, students.
Good afternoon.
Okay, thank you. Sit down. We're on the topic on rocks, and what we have covered so far with our work in geography is we have looked at the igneous rocks. We also have looked at the definition to sedimentary rocks and the way in which different sedimentary rocks are actually formed. And we also looked at the information on sediments. Today, what I'd like us to also continue on with will be still on sedimentary rocks, and we are going to look at more activities to finish off our work on sediments. Recapping now on what we have covered already on sediments. We said that most of the sedimentary rocks, they're actually formed from loose grains of sediments. So generally, when we look at sedimentary rocks, they are formed from loose grains of sediments. And we also noted from our last lesson that sediments include such particles as sand on the beach, mud on a lake bottom, dust particles settling out of the air, boulders on riverbeds, and etc. These are some examples of sediments. We also looked at how we can classify or identify the different sediments according to the grain size. And we looked at, for example, if we looked at that photograph, we have an information showing us sediments along a river bed. The second photograph shows us examples of sediments along the coastline. And we had a table of which that table also looked at how we can identify the different sediments according to the grain size. If we look at the first column on the table, it contains diameter in millimeters, and the second column contains now the different sediments. And we started off by looking at boulders. Any sediment which is classified as having a diameter of 256 millimeters or more is considered to be a boulder. Any sediment which has a diameter of between 64 to 256 millimeter can be considered as cobble. Any sediment which has a diameter between 2 millimeters to 64 millimeters, we can classify that sediment as a pebble. We also looked at if sediments have diameters of 1/16 or between 1/16 to 2 millimeters, then those sediments can be classified as sand. And for us to imagine sand, we can think about the beach, and then from the beach we can know what the sand grains would actually look like. Okay, then we have sediments which are between 1/256 to 1/16 millimeters in diameter are considered to be silt. And finally, anything smaller than 1/256 millimeters in diameter are considered to be clay. Those then gave us information generally on how we can identify or classify the different sediments according to their grain size. That information you also have in your exercise book. Okay, we also went ahead to looking at sediments are actually, or when they are actually formed, they don't just sit on the surface of the earth and stay there forever. The process of weathering, the process of erosion get to actually act on those sediments. And in the process of erosion, that's when transportation comes in. And in transportation, there are two processes that actually take place, which results in contributing to shaping up the sediment or further arranging those sediments. And those two processes that we looked at were the process of rounding, which comes together with transportation. And in rounding, we also noted that it had mainly to do with the grinding away of sharp edges and corners of rock fragments while they are being transported. That process under transportation is known as rounding. And sediments also get to be sorted when they are being transported. And in sorting, this is when sediment grain are selected and separated according to the grain size. I gave an example on rivers. Rivers do the work of transporting also beside eroding and the breaking down. So while the materials have been transported along the rivers, you can see the sorting process if you select a particular river to look at. At the start of that river, you will find that the sediments tend to be larger. And as you get to the end of the river, the sediments get to be very small or fine. And that is where sorting comes in, where the grains are selected and separated according to the size. Okay, with those two processes, we also noted that while the sediments have been transported, do they get to be transported forever and ever? Dorothy says no. So if they do not get to be transported forever and ever, what happens to the sediment then? Dorothy, what do you think? So we're looking at the process of transportation of sediments. Rounding takes place, sorting takes place. But the sediments which are transported do not get to be transported forever and ever. You agreed with me because you shook your head. So I'm asking what happens then to those sediments, or what would be the next process or stage that might come in?
They are deposited on riverbanks.
Okay, very good. Not only on riverbanks, but they are generally deposited. They could be sediments moved by ice. They could be sediments which are moved by river. They could be sediments which are carried by the wind, and etc. So all those sediments then get to be deposited. So if we had to look at the definition to what deposition is, Silo, can you tell me what is deposition, or what would be a simple definition you can give for deposition?
The settling of eroded materials.
Okay, good. So if we're looking at sediments, we're looking at the settling of those sediments. Those sediments get to be settled. And do they form sedimentary rocks as soon as they are deposited or settled? Do they form sedimentary rocks straight away, all those sediments which have been deposited? No. So what would be the next process that will take place before they can be formed or changed into sedimentary rocks? Luisa, what would be the next process before we come to the formation of a sedimentary rock from those sediments?
The lithification process takes place.
And what does the lithification process involve?
It converts the loose sediments into the sedimentary rocks by compaction and cementation.
Okay, good, very good. We already looked at lithification. That's the next process that takes place with the sediments. And lithification is simply looking at the process that converts those loose sediments which have been deposited into sedimentary rocks. But there are two important stages that occurs, and that is the process of compaction, or the stage of compaction. And compaction alone will not form the sedimentary rocks because cementation will have to also take place. We looked at an example, and the example, after deposition, we had some sediments which have been actually transported and which are now deposited. And if we look at the diagram, it showed us samples of quartz, which is a mineral. We looked at a sample of feldspar. And here we might also have different minerals which have been actually deposited. But note, when those sediments are deposited, note the pore space in between the sediments. This is not a compact rock to be called a sedimentary rock yet. This is only the first stage when all those sediments are deposited. So you can note the pore space is actually wider or bigger between those different sediments. Then what happens is that those sediments then go through the process of lithification. And in lithification, that is where compaction and cementation comes in. Here, the rocks now, or sorry, not the rocks, but the sediments are actually overburdened. And they are overburdened by the other sediments which will be later deposited on top of them. So that arrow there shows the overburdening of those sediments laid earlier on by the other sediments on them, resulting in the process of compaction. When compaction takes place, note, what will happen now in compaction is that the pore space will be reduced. Excess water which is accumulated within the pore space are also removed. This is when we say the process of compaction of those sediments has taken place. But that's not all. Because after compaction, note that as the underground water moves through the remaining pore spaces, solid material which are called cement can precipitate in the pore space, and it can bind the loose sediments or the loose sediment grains together to form a solid rock. And that's where we have a sedimentary rock being formed. So note, the next stage then after compaction comes cementation, and that is where you can see from the diagram here the yellowish color in there shows us there the process of cementation has actually taken place now, and through that process the sediments are actually bounded together. And when they are bounded together and they are compact, then we can classify them as sedimentary rocks. Okay, we happy with that? Okay, good. Then we move on. Today we are going to look at one more example so that we understand these processes well. And the example that we are going to look at will be an example of lithification of the sediment of mud and silt. What happens when mud and silt or they go through the process of lithification, that is compaction and cementation? What do you think might happen? It will definitely form a sedimentary rock, but what sedimentary rock are we looking at here? Let's check this one out and see this particular example. Okay, so we're doing one more example of the process of lithification of sediments. But this time we're looking at the sediment mud and silt. Note, you're going to look at the diagram very shortly, but from the diagram it will tell you that when you look at the particles from the diagram, which will come up or appear on the monitor, it will show you the randomly orient silt and clay particles in wet mud. And this is what it would look like. The lines here, or the black color here, represents the orient or random orient arrangement of particles within the environment of a wet mud. So we're looking at silt and clay particles or sediments here. This is how they're actually arranged. Stage 1, deposition. In stage 2, particles reorient. Some water is actually lost and pore space decreases. We know that already from this example here. This stage is the stage of compaction. Note the diagram. See the way now in which those particles of mud and silt are actually rearranged in comparison to the first diagram. Weight of the new sediments on top of that wet mud environment, resulting then in compaction taking place. Excess water is actually removed or lost. Note also that splitting surfaces in the cemented, this time we are looking at a rock now which has been formed after that process of lithification of mud and silt, and that is the cemented shale, which form parallel to the orient mineral grains. And let's look at the diagram now to show that. See the way in which the particles have been arranged, and through the process of compaction and cementation, what would happen now is there could be a splitting surface that might appear along where those silt and mud particles or sediments have been arranged. And this is the time whereby the rock or the sediments are also cemented to form the sedimentary rock, which is referred to as a shale. So shale is a sedimentary rock, and it is formed through the stages that I have just gone through. Okay, note two important words I'd like us to be also aware of. And in the cementation of shale, a sedimentary rock, the word facility is actually used, and facility is basically to do with the splitting capability of the rock of shale. It can split easily because of the way in which the particles have been arranged. That's number one. And the other thing that we need to also be reminded of with this example here is that the splitting takes place along the surface of the very thin layers in the shale itself, which are called laminations. So if we had to put in maybe the line to show where splitting may take place, that line then will be referred to as laminations or lamination. The ability of the shale to split according to the lamination is referred to as facility. And it is through the process of lithification that the rock shale is actually formed, a sedimentary rock shale. Okay, any questions before we do some activities? No questions? Okay, if there are no questions, we'll work on the three activities. And the three activities I'd like you to work on. The first one, I'd like you to describe with sketches in your exercise book how wet mud compacts before it becomes shale. So I've just gone through the process of how shale is formed. You are going to sketch the information in your book and also explain how wet mud compacts before it becomes shale, number one. Number two, activity two, I'd like you to make a list of the clastic sediment particles in order of decreasing grain size from what we have covered already. So you might need to look at your table to help you with the listing in order of decreasing grain size. And number three, note what type of sedimentary rock is actually formed mainly from the following sediments. And the sediments are one, or A, sand. What type of sedimentary rock do you think would be formed from sand sediments? B, what type of sedimentary rock would actually be formed from silt? What type of sedimentary rock would be formed mainly from clay and silt? C, so those are the three sedimentary rocks I'd like you to actually make note of that are formed from those three sediments. We are going to do these activities in maybe pairs or in threes so that we can complete the work a little bit more quicker. So let's discuss, and then from your discussion, you write your answers in your exercise book. I'll give you at least 6 minutes for the completion of those three activities. 6 minutes? Okay, let's have some discussions, and then from our discussions, we'll have the answers written in our exercise books. Noel, you're going to come up to the front and do a quick sketch of what you have got down. And Susan, as well as Terence, are going to help, because you've discussed this as a group, with the explanation of what you have got down on your sketch. Okay, quickly, Noel and Terence and Susan can also come up here to help with the explanations. That's not all, the explanation of it. Can we also explain what we are showing out here on the board? Yeah, microphone. Mic here. For the explanation, you could maybe just explain to the class what you have got on the board. And the rest of us, while they're getting organized to explain what they have put up, the question again, it was for you to describe with sketches how wet mud compacts before it becomes shale.
Firstly, in this diagram, you can see particles of silt and clay, which are randomly arranged, meaning not in order.
The second stage is when the particles of silt and clay are reoriented, they become leveled, equaled, and the weight of new sediment presses down onto the particles. Thank you. Read this sentence here and come down.
Terence, come and stand on this side. And that diagram, yeah, okay.
Lastly, the splitting takes place around the surface of very thin layers.
I think as it is, the students have explained definitely the processes that shale goes through before it can become a sedimentary rock of shale. The important point those three students have made note of on the board, note the arrangement of the silt and the mud particles randomly. That means, as explained by Noel, not in any order. You can see that the particles are randomly arranged, not in any order, not in any form. Then compaction takes place, and upon compaction, you can see some kind of order now being formed with those silt and clay or mud particles. You can see the lines, or you can see the alignment as those sediments reorient as a result of the compaction of other sediments on top of them. Then finally, the stage 3 part, whereby cementation takes place, and here the compaction then of silt and mud resulting in the formation of a sedimentary rock known as shale. But note also, they have made note of the splitting surface, which is supposed to be laminations, and also the ability of this particular rock to split, given the term fissility. So fissility is the term we use to referring to the ability of shale to actually split, and lamination is generally the surface where splitting takes place. Good. You check your diagrams. Your explanation should be similar to what our students have put up here. We move on. Question number 2. We're looking at the clastic sediment particles in decreasing or in order of decreasing size. Val is going to give us the answer or the answers for question number 2.
Boulder, Kobe, pebble, sand, silt, and clay.
Okay, again, the rest of us, we're making corrections.
The sediments from decreasing order: boulder, Kobe, pebble, sand, silt, and clay.
Okay, very good. So we're looking at from the biggest sediment to the finest and the smallest. So we start from boulder, cobble, pebble, sand, silt, and clay. And finally, Frank, question number 3. What type of rock is actually formed mainly from the sediment of sand? Frank?
Sandstone is formed from the sediment of sand.
Okay, very good. He's got sandstone. The rest of us check. Do we have sandstone? Well done. Gideon, B. What type of sedimentary rock is formed from the sediment silt?
Siltstone is formed from the sediment of silt.
Okay, very good. We have silt stone, which is a sedimentary rock formed mainly from the sediment or sediments of silt. And finally, Kathy, clay and silt. What type of sedimentary rock can actually be formed where the sediments are mainly of clay and silt?
Shale.
Okay, we've just done this, and I hope you picked that up also. Shale, a sedimentary rock which is formed mainly from sediments of clay and silt. Okay, we double check and make sure we have those answers, and also the answers are corrected in your exercise book. That will also bring us to the end of our lesson. Class, if you can now stand up. Okay, to the pilot teachers, our keyword for lesson 56 is litification. Good afternoon and thank you, students.